Hi everyone, today we will see a problem from moment of inertia. So the question goes as from a thin uniform disk of radius 2r, another disk of diameter 2r is removed. So there's a thin uniform disk of radius 2r and its center is O. From this thin uniform disk, another disk of diameter 2r. That means another disk of radius r has been removed from this bigger disk of radius 2r. Now we have to find the moment of inertia of remaining disk. That is, after removing the smaller disk, the bigger disk has some remaining parts, and we have to find the moment of inertia of the remaining part. So let's shade that part. So now it's actually equivalent to the moment of inertia of the remaining portion is actually equivalent to the moment of inertia of the bigger disk minus moment of inertia of the smaller disk. So let's say the bigger disk A and let's say the bigger disk I mean the smaller disk BB. So its radius is 2r and its radius is r. Since the area of both the disk varies, their masses will also be different. Hence, we will have to find the masses of both of them separately. Let's say the mass of a bigger disk BMA, so which will be proportional to the area of the bigger disk, which is pi into 2r the whole square. So this is equal to k into 4 pi r square. So I have introduced a proportionality constant in order to remove the proportionality. So ma is equal to k into 4 pi r square. So now mb would be proportional to m into pi r square, which will be equal to k pi r square. So let's say this k pi r is equal to m. So this 4 into k pi r square will be 4m. Now we know the masses of both the disk. Now we have to find the moment of inertia of both the disk. So the moment of inertia of A about 2, we have to find the moment of inertia about 2. So that's quite important to be noted. So moment of inertia of A about 2 would be equal to mr square by 2. This mr square by 2 is the general formula for the moment of inertia for a disk about its center of mass and perpendicular to the plane. So here for A, the mass is 4m. So 4m and the radius is 2r. So 2r the whole square by 2r the whole square by 2, which is equal to 4m into 4r square by 2, which is equal to 16r square m by 2, which is equal to 8mr square. So the moment of inertia of A about O is 8mr square. Now we will find the moment of inertia of B about O. So basically the formula for moment of inertia for a disk is mr square by 2, and but we have to find but here we have to find the moment of inertia of B about O. So this is for the bigger disk, this is center O, but for the smaller disk, the center will not be O, it will be O dash, and the point O will be at the circumference of this smaller disk, because we have removed the smaller disk from the bigger disk such that the circumference coincide with the center O of the bigger disk. So basically the center O will be at the circumference of the smaller disk, and the center of the smaller disk would be O dash. So we know that mass of the smaller disk is m. So m, and radius of the smaller disk is also equal to mr square by 2. And this is this formula is for the moment of inertia of a smaller disk about O dash, but we have to find it about O. So basically we will use parallel axis theorem, which is equal to the moment of inertia about O dash plus the distance between the axis of rotation. So here the distance is mr square, so we will add mr square. So we will be getting 3 by 2 mr square. Now we have to find the moment of inertia of the remaining portion, which is I remaining about O is equal to IA about O, IB about O. So which is equal to IA about O is 8 mr square, and IB about O is 3 by 2 mr square. So 8 mr square minus 3 by 2 mr square, which is equal to 13 by 2 mr square. But the question is not over yet, because in the question the mass of the remaining portion is given as m. So we have to use the value m, not the capital M. So we will find the relation between both the capital M and m. So we know that the mass of the remaining portion would be equal to the mass of the bigger portion minus smaller portion. The mass of the bigger portion is 4m. The mass of the smaller portion is m. So 4m minus m will give you the mass of the remaining portion, which is given as m. So 3m is equal to m, which means m is equal to m by 3. So we will substitute here. So we will be getting 13 by 2 m by 3 r square, which is equal to 13 by 2 3 are 6 m r square. So I remaining about O is equal to 13 small m r square by 6. So this would be the answer for this question.